Hello YouTube, this is Tutor for Hire again, back with a new video. This will be the third installment of the calculus series, and it's just going to be based off the first two videos. It's going to be expanding on what we've been talking about, and I want to make these videos a lot shorter, so I'm going to try to keep all the videos under 10 minutes so we can get in and get out. I know watching a video for over 10 minutes can be tedious, so I'm going to try to make them as short as possible. So starting with this new video, we're going to start with a little bit of review of what we talked about in the first two videos. We talked about what functions were, and we talked about their rates of change. And by the way, I'm no longer going to use the term growth rate because that applies specifically to a certain rate of change. Rate of change is a general term for derivative form, which we'll talk about a little bit later, but it's basically all the same stuff. So let's say this function measures the height of a graph or something like that, and then they ask you for what is the the rate at which the slope is expanding, and then you'll go, okay, and this is measured in, this is the growth rate of the function. That would be a correct terminology. However, in a case like this, and by the way, this is the same exact problem and it's going to involve the same exact processes to solve it. Let's say that this function measures the distance that an automobile drives, and they say, well, what is the speed? You're still finding the rate of change of the function. You're still finding the rate at which it expands. It's just you're going to measure it differently. So you're going to say this is the velocity. You're not going to say this is the growth rate. You're going to say this is velocity. So from now on, all these derivative forms, I'm going to call them the rates of change of the function. I'm no longer just going to say the growth rate of the function. So the rates of change will be the new terminology. And we talked about two ways in which you could figure out the rate of a change of a function. The first one is through computing the function, or the ratio, the changing ratio of a function with a limit. And we're going to get into that much later, so right now we're not going to talk about it. But the second way is through rules. And I have a couple rules, and basically the way you do it with rules is you have a rule and you can apply it to a vast number of circumstances, and you can extrapolate it to different circumstances. So and I have a couple rules for you guys right now. So what is the rate of change for a function when it is a constant multiplied by an isolated variable? So just a variable with no exponents, no anything. And the constant, as we talked about before, a constant is just a solid number. It could be 3,000, it could be whatever. And the variable is by itself. It has nothing else attached to it. What is the rule here? Well, the rule is that the rate of change will be the constant multiplied by the rate of change of the isolated variable. And in this circumstance, when x, or when a variable is by itself and it has nothing attached to it, no exponents or anything, its rate of change will always be 1. That's the first rule that we're going to talk about. And then the second rule comes right after and relates back to this problem, is that when you have a constant multiplied by a isolated variable, it's going to be c multiplied by 1 because the variable turns into 1, and therefore the rate of change will just be c because anything multiplied by 1 is basically itself. So that is the rule. So if you have a function that looks like this and it says a constant multiplied by x, that's going to equal the rate of change will be c. So that's the second rule. And the last rule that kind of relates to this will be, what if you have something that looks like this? They ask you, what is the rate of change for just a constant with no variables? The answer will always be 0. So constants have no relationship with the rate of change. And this is in part logical because if you think about it, okay, so let's look at a function like this. Y sub x equals 2x plus 35. The 35 is the constant number, and this is the slope, and this is you're going to get the rate of change from this number. You're not going to get it from the constant because the constant turns to 0. And you have to ask yourself why. Well, let's say we're looking at a function. Let's say this function measures distance. So it starts at the point 35, and then it increases with the slope of 2x past the 35 point, right? If the problem asks what is the speed at which the speed of the function, that has no relationship to 35 because the 35 is just a starting point with respect to the distance. It has no relationship with how fast the graph is going or how much it's expanding, or it has nothing to do with the growth, the rate of change of the function. It's merely like a starting point. So because it has no relationship with the slope or with the rate of change, it will always be 0. So it'll always be constants on their own with no variables will always be irrelevant with respect to a function and finding its rate of change. So that'll just be, you'll cancel that out, so that'll be 0. And then for this one, as we talked about before, when you have a constant multiplied by x, it will always just be the constant. So it'll be 2 plus 0, which is equal to 2. And that'll be the answer for that one if they ask for the rate of change. So, and that's pretty much it. I mean, if you guys, that's what we're gonna get into more and more is, when we have a function and we want to get its we want to get the next form of it that measures the rate of change. This is called differentiation. This process, it's called differentiation. And when you want to go backwards, so say you have 2 and you want to figure out how to get to 2x, and you want to figure out that process is called integration. But they're both essential. And basically, this 2 is what's called the derivative of 2x. So this is, it's better to just say it like it is now because it'll come out later. But the derivative of 2x is equal to 2. That's basically it when you find the rate of change and things like that. And as we talked about before, there are a lot of ways you could do it. Even like, let's say, well, what is the rate of change for 3x plus 4? Let's say this is a function, right? What are we trying to find when we're trying to find the rate of change? As we talked about before, the rate of change of a function corresponds to its slope on the graph. So what is the slope of this? As you can see, this is also another rule you guys might probably already know about. Y equals mx plus b is what's called slope-intercept form, and this is perfectly what's in it. This is another rule. When you have something that looks like this, the slope will be m. So in this case, the slope will be 3 because it's right next to the x, and that would be the case with that. And there are other ways you can find the slope too. You could plug in points. So let's plug in something like, and because this function is linear, we can do it. All linear functions, the slopes remain constant. So if you plug in, basically that means if you plug in 1 point, you know the slope slash derivative, etc. for all points. So let's see here. Let's plug in 1 and 2 for this function. So x of 1 would be 7, and then x of 2 would be 10. And so what are we going to do here? We're going to do 10 minus 7, which is 3. 3 over 1 is equal to 3. And as you can see, the slope here is equal to the slope there. So, and it seems my time is running up. I'm trying to keep it under 2 minutes. But I think that just about covers this right now. So I thank you guys so much for watching. But yeah, the main thing is slope-intercept form. We have a couple new rules for finding derivatives, and just know that all of this stuff fits together. You know, the slope of a linear function is equal to its derivative, like its rate of change. These are all like interconnected, and they all have different terms for them, but they're all pretty much the same. So another way you could find the slope is the slope can be across over up, right? And again, when we're looking at this is another reason why the constant number is irrelevant in determining the slope or the rate of change or the derivative, is because when we're looking at a function like this, so let's say y sub x equals to 3x plus 4, we don't really care about the fact that it starts here. We're just trying to look at how much it's expanding by. So in a particular instance like this, it goes up 3, 1, 2, 3, then it goes across 1, right? So it'll be, if we're looking at the across up thing for determining the slope, it'll be 3 over 1, which is equal to 3, which is the slope again, as we talked about. It's a slope, it's the rate of change of the function, it's everything. So these are all connected, and these are some of the rules for determining the derivative or the rate of change. And when you're finding the rate of change, you're using differentiation. When you're finding the function from the rate of change, you're doing integration. And so keep all of this in mind. We're going to keep going, and I thank you so much, guys, for watching. Appreciate it. Talk to you soon.
Just a quick PSA for everyone out there. I just ran 5 miles. It's very late out right now. But, you know, it's so important to boost your productivity is to get out there and just get active. You don't want to be the student that maybe is good in the classroom, but, you know, has a big belly or man boobs or any of that stuff. So you got to get out there every day. You got to get it in terms of the studies, but also in terms of the physical, because you can't have a healthy mind, you can't have a healthy brain without a healthy body. So make sure to stay fit, stay active, have a good diet, and just keep it going. Make sure you're all around good, because you'll feel a lot better on test day when you get in there, and you have a strong body too. I prefer to work at night. Maybe you guys prefer to work in the morning, but make sure you get it done. I would recommend on either the morning or the night, just so you have the full day to be productive in other ways, because this should be like something that you do on the side, but make sure to do it. It may be, these are exercises easy to do, but it's also really easy not to do. So, you know, just make sure you get it, and yeah, take care, guys.